Welcome to episode 39, Compute on Google Cloud, The Choices, where we explore the range of compute services Google Cloud provides and how to choose the right one for your workload. Cloud computing is no longer a single concept. It's a spectrum of models that balance control, scalability, and simplicity. Google Cloud offers everything from virtual machines to fully managed serverless platforms, each designed for a different level of abstraction. The challenge for teams is not lack of options, but knowing which one fits their application's behavior, growth pattern, and operational maturity. This episode guides you through the major compute offerings, what makes each unique, and how to match them to real-world needs. The best platform is the one that delivers required performance with the least complexity. Compute Engine provides flexible virtual machines that form the foundation of Google Cloud's infrastructure as a service layer. It gives administrators fine-grained control over CPU, memory, disk type, and networking while benefiting from global scalability and uptime. Compute Engine suits workloads that rely on traditional architectures, custom operating systems, legacy software, or specialized drivers. For example, a company migrating on-premises databases or running licensed enterprise software can mirror its environment almost exactly in Compute Engine. Managed instance groups, auto-scaling, and preemptible VMs extend efficiency and resilience. This choice maximizes configurability, but also demands operational oversight. Patching, monitoring, and scaling policies remain the customer's responsibility. Compute Engine is ideal when control outweighs convenience. Google Kubernetes Engine, or GKE, offers managed orchestration for containerized applications. It automates deployment, scaling, and lifecycle management of containers using the open-source Kubernetes framework. GKE strikes a balance between flexibility and automation, giving developers cloud-native scalability without manually handling cluster internals. For example, a retail analytics platform might run microservices in containers across multiple zones, scaling pods automatically during peak traffic. Google manages the control plane, security patches, and upgrades, reducing operational burden. GKE supports hybrid and multi-cloud strategies, integrating smoothly with Anthos for consistent policy enforcement. This platform suits teams adopting DevOps or microservice architectures that value portability, standardization, and efficiency across complex distributed workloads. Cloud Run provides a fully managed, serverless container platform that abstracts away all infrastructure. Developers deploy stateless applications or APIs packaged as containers, and Cloud Run scales them instantly based on demand, from 0 to thousands of instances automatically. You pay only for the milliseconds your code runs. For example, a media processing service might trigger containerized workloads when new files appear, scaling down when idle. Cloud Run supports any language or runtime that fits in a container, offering flexibility with minimal operations. It's ideal for modern web services, APIs, and background jobs where developers want container control but without cluster management. Cloud Run embodies the serverless promise: simplicity, speed, and cost efficiency driven entirely by usage. App Engine provides a platform-as-a-service environment for building and hosting web applications without managing servers. It offers both standard and flexible environments, supporting popular languages like Python, Java, and Go. Developers focus on writing code, while Google handles scaling, load balancing, and patching. For instance, a startup could launch a customer portal on App Engine that automatically scales with user growth and includes built-in versioning for safe rollouts. The standard environment optimizes for rapid deployment with predefined runtimes, while the flexible option allows custom dependencies and more memory. App Engine suits applications following conventional web patterns that need high availability and automatic scaling but minimal operational overhead. It's a natural choice for digital services that must evolve fast without infrastructure friction. Cloud Functions deliver lightweight, event-driven compute ideal for microtasks and automation. They execute single-purpose functions in response to events such as file uploads, database changes, or messages from PubSub. Each function scales independently and bills per invocation, eliminating idle cost. For example, a function might resize images as they're uploaded or trigger an alert when new data enters a pipeline. Cloud Functions simplify integration by reacting to events across Google Cloud and external services. They suit glue code, lightweight APIs, and real-time automation where responsiveness matters more than sustained runtime. Their greatest strength is simplicity. No servers, no scaling logic, just code that responds when needed. For modular, event-oriented workloads, they're a precision tool for agile architectures. Batch is Google Cloud's managed service for batch and high-performance computing workloads. It automates job scheduling, resource provisioning, and execution across large-scale compute clusters. Batch simplifies complex workloads like rendering, simulation, or genomic analysis that require parallel processing but not continuous uptime. For instance, a research lab can run thousands of compute-intensive jobs overnight, paying only for the time used. The service handles failures, retries, and dependency chains automatically. Batch supports both CPUs and GPUs, integrating with storage and orchestration tools for full pipeline automation. It turns what was once the domain of specialized schedulers into a managed, cost-efficient service, opening high-performance computing to a broader range of industries without requiring dedicated infrastructure expertise. Bare Metal solution addresses specialized workloads that require physical hardware and cannot run effectively on virtualized infrastructure. It provides dedicated, high-performance servers co-located near Google Cloud regions, connected with low-latency networking. Typical use cases include legacy databases like Oracle, specialized licensing models, or ultra-low latency trading systems. Bare Metal solution allows these systems to benefit from proximity to cloud services such as analytics, storage, and backup without rewriting applications. It's a stepping stone for modernization, enabling hybrid environments where legacy performance meets cloud integration. While it lacks elasticity, it provides consistency for workloads that depend on specific hardware or configurations, extending Google Cloud's reach to the last holdouts of on-premise dependence. Selecting a compute option depends on key drivers such as latency, scale, and control. Latency-sensitive applications like gaming or trading favor local compute or edge-integrated Cloud Run deployments. Scale-driven workloads like analytics pipelines or e-commerce backends thrive on GKE or App Engine. Control-heavy tasks such as custom databases or system-level tuning suit Compute Engine. Evaluating these drivers ensures architecture fits performance expectations. For example, developers needing millisecond responses may choose Cloud Run near user regions, while compliance-heavy workloads remain on bare metal until fully validated. Matching drivers to platform capabilities prevents both over-engineering and underperformance, ensuring that compute choices align directly with business outcomes. Integration across networking, storage, and identity unifies Google Cloud's compute ecosystem. Each compute option connects seamlessly with virtual private cloud networking, cloud storage, and identity and access management. This cohesion simplifies policy enforcement, data movement, and secure communication between services. For instance, a Cloud Run API can access BigQuery securely through service accounts and VPC connectors, while a GKE cluster uses shared VPC networking for centralized oversight. The platform's integration ensures consistent governance without blocking flexibility. Modern architectures depend on this mesh. Compute is just one piece, but when integrated, it becomes part of a secure, high-performing ecosystem that spans data, connectivity, and collaboration layers. Cost models vary by service and reflect levels of abstraction. Compute Engine charges per virtual CPU, memory, and storage, often discounted through sustained or committed use. GKE adds container orchestration overhead but benefits from node-level efficiency. Cloud Run and Cloud Functions charge per request, execution time, and resources consumed, aligning costs directly with activity. App Engine balances predictable scaling with per-instance hour pricing. Batch optimizes for transient workloads, while bare metal follows dedicated hardware billing. The guiding principle is alignment match, pricing models to workload patterns. For example, unpredictable traffic favors per-request billing. Steady-state compute favors reservations. Understanding these cost dynamics prevents surprises and supports proactive budgeting in dynamic environments. Operational effort decreases as you move up the abstraction ladder. Compute Engine requires the most management, patching, scaling, and monitoring each instance. GKE automates much, but still needs oversight of container orchestration. App Engine, Cloud Run, and Cloud Functions handle infrastructure fully, freeing teams to focus on application logic. Batch and bare metal occupy specialized corners. Batch automates complexity. Bare metal preserves control. The key trade-off is flexibility versus simplicity. High control options enable customization but increase responsibility. Managed options simplify operation but constrain configuration. Choosing wisely means assessing where your team's expertise and business priorities lie, ensuring operations stay sustainable without overextending skills or budgets. A practical decision tree can guide compute selection. Start with your workload's nature. If it's an event-driven function, choose Cloud Functions. If it's a stateless containerized service, choose Cloud Run. For long-running or modular systems, consider GKE. If the workload demands full control or uses specialized hardware, Compute Engine or Bare Metal fit best. App Engine works when rapid web development and scaling matter most, while Batch suits compute-heavy, non-interactive jobs. The golden rule is simplicity first. Adopt the smallest platform that meets your needs and evolve as complexity grows. This structured approach prevents over-engineering and keeps architecture aligned with practical goals rather than trends. Choosing the smallest effective platform defines modern compute maturity. Each Google Cloud service offers a balance between control, scalability, and abstraction. By understanding trade-offs between autonomy and automation, cost and convenience, teams can pick wisely. Start simple, validate performance, and scale sophistication only when justified by value. The goal is not to use every service, but to use the right one confidently. When compute choices align with workload behavior and team capability, systems stay efficient, secure, and adaptable. Google Cloud's compute portfolio provides the tools. Success depends on choosing the minimal platform that delivers maximum outcome, fast, reliable, and built for continuous evolution. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.